Okay, section 4.4, indeterminate forms and L'Hopital's rule. L'Hopital's rule is all about limits. Limits for indeterminate forms. So what is an indeterminate form? Well, suppose we wanted to find the limit as x approaches 1 of the natural log of x over x minus 1. When we try to just do the plug and chug, we end up with 0 over 0. That is an indeterminate form. Sometimes when we have an indeterminate form, we can do some factoring and canceling. Sometimes we can use a geometric argument or use the squeeze theorem like we do for sine of x over x. Other times we use what is called L'Hopital's rule. I am not going to prove it to you. Another indeterminate form is infinity over infinity. So the thing I want you to remember is if you have an indeterminate form, you can use L'Hopital's rule. Indeterminate. So in order to use L'Hopital's rule, you must have 0 over 0 or infinity over infinity. You can't have 0 over infinity. And the basic gist of L'Hopital's rule is if you have an indeterminate form, the functions themselves and their limiting values behave like the ratio of their derivatives. So you can take the derivative of the top and the derivative of the bottom. Don't quotient rule. Derivative of top, derivative of bottom. Let's see, it's also valid for one-sided limits. And if you have plus or minus infinity, it's still an indeterminate form. It doesn't have to be just positive infinity. So let's look at that very first example that we had there. Limit as x approaches 1. The natural log of x over x minus 1. Now usually when I work these problems, I like to draw a little arrow up to the side and show what I get when I plug it in. Natural log of 1 is equal to 0, and 1 minus 1 is equal to 0. Then I just write equals the limit as x approaches 1. I take the derivative of the numerator and the derivative of the denominator. Then I have something I can plug and chug. Often in books you'll see limit as x approaches 1, natural log of x over x minus 1 equals with like a LH for L'Hopital's rule, or just an L, something to indicate that you're using L'Hopital's rule. And yes, sometimes you'll see it spelled LHopitals. It's still the same thing. It's still L'Hopital's rule. I like showing what indeterminate form I have. It kind of keeps me honest rather than just saying, oh, I'm L'Hopitaling this. So there's your indeterminate form. We apply L'Hopital's rule, and now we have some practice problems. So I'm going to let you do them. Give them a try. See if you can do them without L'Hopital's rule. There are 2 of them I can see off the top of my head that you can do without using L'Hopital's rule. See if you can figure out which ones they are, and we'll meet back here in a minute and compare answers. I don't know about you, but that took me a few minutes. Number 1, L'Hopital was optional. because x cubed plus 8 is a sum of two cubes, which you can factor. But it was optional because it was an indeterminate form. You get 0 over 0, and you get the same answer whichever way you do it. Of course, you would have to, otherwise the rules of math would be wrong. Number 2, indeterminate form, straight out L'Hopital. Number 3, straight out L'Hopital. 4. 5, you had to L'Hopital more than once because we ended up with 0 over 0. We got 0 over 0 again. We got 0 over 0 yet again before finally getting 2. And then number 6 was not a candidate for L'Hopital. You cannot L'Hopital because you get 0 over 2, which is just 0. That's not indeterminate. So those were all examples of L'Hopital where you have the initial L'Hopital ready indeterminate form. Sometimes we have a different type of indeterminate thing, like an indeterminate product. We need an indeterminate quotient in order to L'Hopital it. But a product can easily be made into a quotient because f times g is equal to f divided by 1 over g, because what is fraction division but invert and multiply. So let's look at example 6. We have the limit as x approaches 0 from the right, because natural log of x only exists from the right. When I plug 0 in here, I get 0 times negative infinity, actually, because as you approach 0 from the right, natural log shoots down to negative infinity. So, if you have 0 times positive or negative infinity, you can rewrite it. Now, I usually put the more complicated thing on top and 1 over the simpler function on the bottom. This is equal to the limit as x approaches 0 from the right. I'm going to leave natural log of x on top and put 1 over x down below. Remember, this is natural log divided by 1 over x, which is the exact same thing as invert and multiply natural log of x times x. But now, if x goes to 0, I have negative infinity over infinity, which is a L'Hopital ready indeterminate form. Limit as x approaches 0 from the right of 1 over x over, this is x to the minus 1 power, so minus x to the minus 2 power. Now, if you're a fan of negative exponents, you could rewrite it with just negative exponents. And if you remember your rules for exponents, it's always top exponent minus the bottom exponent. So this is the limit as x approaches 0 from the right of x to the minus 1, and it's negative, minus negative 2. Or you can look at it as 1 over x divided by, excuse me, 1 over x squared, which would be 1 over x times negative x squared, which is just negative, plain old x. Either way, it's 0. There's the pretty answer. Yeah, you absolutely could have written it as x over 1 divided by the natural log of x, but that makes your life harder, and why make your life harder when you don't have to? So, I'm going to give you a chance to do these. I am going to tell you if you have a negative exponent, like you do in this one, then why make the other one have a negative exponent? Just put that one down below. Let's meet back here in a minute and compare answers. Not too bad. First one I rewrote, I put the 1 over x in the bottom instead of 1 over sine of x, because it's just easier to differentiate sine than it would be to differentiate cosecant. And I ended up with pi. And then in the second one, I did exactly what I suggested. I put the thing with the negative exponent on the bottom, differentiated, got 0.